Here we have a problem dealing with buoyancy, so let's look and see what we have. I'll draw a diagram here. So we have a balloon, large party balloon, that weighs 18 newtons when empty. Okay, so the mass of the balloon times gravity is 18 newtons. And the balloon is filled with 3.5 cubic meters of helium, and the density, well, I probably shouldn't put it this way. I should say, instead of saying it's the volume of the balloon, because that'll be confusing, I'll say that's the volume of helium. And then 0.171 kilograms per cubic meter is the density of helium. Because I don't want to get the mass of the balloon mixed up with the mass of helium, right? So the total mass of helium is going to, be related to that. Okay, and then it's held down by a vertically oriented spring with a spring constant that is, and the spring is elongated. So here's our spring. And it has been elongated by some amount x. Right, here's the equilibrium. Okay, so that means that there's a spring force that points down. Right, the spring force is trying to restore the spring to equilibrium. In addition, you've got the weight of the balloon and all the helium inside the balloon. You got the mass of the helium times g, which points down, and then we have the buoyancy force that points up. Okay? So those are the forces acting on the balloon. We've got two gravity sources, right? We've got the gravity of the empty balloon itself, that shell that's holding the helium. We've got the gravity of the stuff inside the balloon, because the helium does weigh something. And then we got the spring force pulling down, and then we got the buoyancy force. All right, so the sum of all of our y forces is going to be the buoyancy force, which is positive. We'll take up to be positive and down to be negative, minus all these other things. So the mass of the balloon times gravity, the mass of the helium times gravity, minus the spring force. Okay, so let's consider what's going on here. So the buoyancy force, well, that's the density of the displaced fluid, which is the density of air, and multiplied by the volume of air. I suppose I should put a hat on the volume, times g. Okay, now the density of air is given in the problem to be 1.29 kilograms per cubic meter. The volume of air displaced, well, the balloon is completely immersed in air. Therefore, the volume of air displaced is equal to the volume of the balloon, which is 3.5 times 9.8. So the buoyancy force is 44.25 newtons. Next, we've got the mass of the balloon times gravity, which is 18 newtons. Okay, so that's the first two terms. And then we have the mass of helium times gravity. Well, that's the density of helium times the volume of helium times gravity, which is 0.171 times 3.5 times 9.8. So that is 5.87 newtons. So that's how much the helium weighs. And then minus kx. Right? And we know k is 110. K for the spring is 110. So now taking my equation down here and plugging in what I know, I've got 44.25 minus 18 minus 5.87 minus 110x equals 0. Okay? So this is the buoyancy force, this is the weight of the balloon, this is the weight of the helium, and then this is the spring force. So that works out to be 20.38 is equal to 110x, and so x is equal to 0.19 meters. There's the elongation of the spring.